Okay, so we'll start now. Two new heterocycles, pyrazole and imidazole. Okay, so in last lecture of last lecture we have finished indole, and now we will start remaining two five-membered heterocycles, imidazole and pyrazole. So here I have shown both of these structures, imidazole and pyrazole. Uh, so how to number that one is I have shown here. So diazoles, these two are diazoles. That means two nitrogen atoms are present in both of these heterocycles. Diazoles. One is imidazole, pyrazole. So how the numbering these imidazole and pyrazole? So everywhere. So pyrazole. First number we have to start from where hydrogen atom attached to the nitrogen atom. At that nitrogen atom, you can number that heterocycle or that particular ring as a number one. Okay, and second atom obviously that one is another heteroatom, so that one is number two, and you can go for then 4 5 and 3 4 and 5. So what will be the case in imidazole? As usual, nitrogen atom which holds hydrogen atom, that you have to number first. Okay, so first one, then where at from where the nitrogen atom, another the next second nitrogen atom is closer. So from here this nitrogen atom is closer, only one carbon is in between these two nitrogen atom. So that's why we have to number in anti-clockwise direction. Okay, so first number, second number carbon atom, third number nitrogen atom, and remaining two carbon atom we have to number fourth and fifth. Okay, so in every heterocycle how to give the numbering, that if two or three heteroatoms are present in one ring, then you have to number according to the rules, like start from the first nitrogen atom or first any heteroatom which is more acidic. Here nitrogen attached to the hydrogen, that's why this nitrogen is more acidic. So that's why we have to number that one is first number. And now we have to go for, we have to count most electronegative element, second electronegative element. So where is the second electronegative most? So nitrogen is the second most electronegative compared to the carbon, and which is closer from this way. Okay, so we have to go in anti-clockwise direction for the numbering of the imidazole. So in this case these are diazoles. Okay, five membered ring, that's why it's a ole. And as two nitrogen atom present, we can call it diazha. Okay, so diazha, two nitrogen atom, ole means five membered ring. Okay, so this is the normal nomenclature of the compound. Now, where the imidazole is present in which things imidazole present? I think here they have given all imidazole containing moieties, which is present in our living organisms. Okay, so this one is histidine amino acid. Okay, histidine NH2 COH amino acid. Imidazole containing amino acids name histidine. Important ligand to many metalloproteins, is one of the essential amino acids. A small change in cellular pH can result in a change in its charge. Okay, so histidine, and after eliminating CO2 we can get histamine, body neurotransmitter and local immune response. This one is acts as a body neurotransmitter. Okay, next carnosine. Okay, carnosine containing carnosine moiety, which contains this COH and imidazole moiety. Okay, so COH group and NH group, and it attached to the imidazole. So that's why this is also very important dipeptide. Okay, this is dipeptide in high concentration in the brain and muscles, improves social interactions and treatment of autism. Okay, so see the how the these heterocycles, they are present in different forms in living species. Okay, so some another important molecules which contains which diazoles like pyrazole and imidazole, in which another things they are present in natural products, pharmaceuticals, agrochemicals I have listed over here. So here is histamine, we have seen inflammatory imidazole. Histidine, we have seen protein constituent. Then caffeine. Okay, in caffeine imidazole is present. Here you can pay attention in this blue colored box I have, that means they have shown the heterocycle, pyrazole, and imidazole. So caffeine, in caffeine, imidazole is present, tea coffee stimulant. Then here 4-methyl pyrazole, 3,5 carboxylic acid, fire sponge, marine natural products. So pyrazole is present here. Pharmaceuticals, in imidazole, cimetidine, imidazole is present. Okay, anti-ulcer agent. Pyrazole is present. Signified citrate is very important. Viagra, erectile it is in dysfunction. So pyrazole is here. Imidazole is also vardenafil citrate. Okay, imidazole is present over here. Pyrazole again, Celecox is also COX-2 inhibitor, very popular drug. Pyrazole, this one Celecoxib. In which agrochemicals all these moieties are present? Pyrazole, fipronil, insecticide, acts as an insecticide, and imidazole, prochlorase, fungicide. Okay, so these are the some of the compound in which our heterocycles they present, and very important all these elements or all these compounds in our day-to-day life. Okay, next one, imidazole and pyrazole. Okay, so we started combine because these two are mostly they are similar to each other, resembling each other. That's why we have to study these two, pyrazole and imidazole, collectively, or simultaneously. We can start both these heterocycles. Okay, imidazole and pyrazole structure and properties. Imidazole, it's a colorless prisms. Okay, melting point 88 degrees centigrade. Pyrazole, colorless needles, melting point 70 degrees centigrade. Bond lengths and protonenamide chemical sheet as expected for aromatic systems. Bond lengths for imidazole I have given over here. Okay, for pyrazole also. Then protonenamide shift given over here for imidazole and pyrazole. Resonance energy, which is very important. Resonance energy, both systems have lower resonance energies than pyrrole. Okay, so we have compared these things, resonance energy, with pyrrole moiety. Okay, so pyrrole contains only one NH bond, so we did compare here resonance energy with pyrrole, which is okay, so have lower resonance energy, less than 90 kilojoule per mole. Electron densities relative to pyrrole, the additional electronegative nitrogen atom. Okay, so in pyrrole we have only one nitrogen atom, and now in imidazole and in pyrazole one more nitrogen atom we have, it has been increased. So that's why, due to additional nitrogen atom, the electronegative nitrogen atom decreases the overall electron density on the remaining carbon atoms. Okay, so compared to the pyrrole, these two moieties, they are less electronegative. That means electron density is lower. uh, okay, so like that. uh, the precise distribution is rather uneven. For imidazole, C4 and C5 are electron rich. Okay, for imidazole, C4 and C5 are electron rich. C2 is electron deficient. Okay, so C2 is highly electron deficient because that one is present in between two nitrogen atom. Okay, so that one is present in between two nitrogen atom, C2. That's why its electron density on this carbon atom is less. For pyrazole, C4 is electron rich. C4 is electron rich. C3 and C5, C3 and C5 are electron deficient. It's really important for even for your electrophilic substitution reactions. For next electrophilic as well as nucleophilic substitution reaction, all these electron density data is very important. Okay, in case of imidazole and pyrazole. Okay, so pi electron density, please pay attention on that one. Both pyrazole and imidazole are significantly less reactive towards electrophilic aromatic substitution than pyrrole. Okay, so this is also important comparison comparative data in between pyrazole and imidazole. So pyrazole and imidazole, they are comparatively less reactive towards electrophilic aromatic substitution than pyrrole. Okay, okay, but pyrazole and imidazole, they are more reactive towards the electrophilic aromatic substitution than benzene. Okay, next one, reactive towards nucleophilic aromatic substitution at certain carbons. Okay, at certain carbons, that means which carbons which are high, real electron density is lower. I think at that point, at that carbon atom, nucleophile can react very easily. Pyrrole which does not react with nucleophile. Okay, that is totally contrast to the pyrrole. If we will compare data pyrazole imidazole with pyrrole, so pyrrole is does not react with nucleophile, whereas imidazole and pyrazole, they are reactive towards nucleophilic aromatic substitution reaction. Okay, so this is the thing for regarding imidazole and pyrazole.